Very small histogram movements, like what we're showing on your screen, can cause different branches to fire. And that created real business confusion. I personally got burned by this in deployment. Although the example I'm using in this video is Android-based computer vision, everything I'm about to show applies equally to desktop computer vision and in any other CV deployment platform. It doesn't matter if your camera is a USB camera connected to a development workstation or a mobile sensor in an app. This phenomenon is universal. This video is for solution architects, designers, and project managers who need to make informed decisions about the financial and time to market risks in computer vision projects, and who want to provision for the unknown hiccups that very often appear late and can significantly delay projects, risk your budget, and delay the benefit realization your project originally planned. Whenever I'm explaining this topic, people expect it to be about model selection or training data or YOLO versus mask RCNN or ONN X optimization. This is not about any of that. This is about something more quiet and more subtle, but much more expensive. I call this branch stability. In every real CV system, you have a pipeline, and inside that pipeline, there are branching decisions, like code branching or logic branching decisions to be made. Example, if hue looks closer to blue, take contour method A. If hue looks closer to purple, take contour method B. And by contour method, I mean contour detection, like a very common operation that we do for recognizing objects or classification tasks in vision-based AI. In development environments, you don't notice the risk inside this, because in development, you feed clean test images, and your branches, your coding or logic branches, based off of those test images, they look stable. But in real deployment, the cameras there, they drift. The white balance in those cameras, that can shift. Illumination, the lighting around that camera, that shifts. And very small histogram movements, like what we're showing on your screen, can cause different branches to fire. By different branches, I mean the coding logic, the decision logic that you write based on how your histogram look, right? That is absolutely critical to which branch you want to fire. So you want the correct histogram to be interpreted and the correct branch to fire. So let's go to a concrete, simple illustration. A single blue square on the face of this Rubik cube. Same physical object, 3 photos, slightly different lighting conditions. To the human, all 3 look identical. But if I show you the hue histograms of these 3 images, you see a subtle shift. Not a huge spike, not a dramatic shape change, just enough of a left-right move in the center of mass. What I call the center of mass is this region here in the histogram. This shift is invisible to the eye. It's normal camera variance, right? But this shift is enough to drift into the fuzzy band between blue and purple here. Notice that I'm not drawing any vertical threshold line. I'm drawing 2. This area between them is the risk band. This is the band where the algorithm isn't certain which color this object is. Inside the code, these branches are usually very simple if-else conditions. If dominant hue is less than a certain boundary, you branch to A else branch B. They look trivial, but they are the source of huge instability because very small drift in histogram center can flip the branch decision. When that branch flips, it triggers a different contouring strategy. And different contouring strategies produce different geometry outputs, bigger or smaller bounding boxes, slightly different contour areas or centroids, slightly different number of edges. Now, here is the part that often shocks people. This is not a theoretical problem. I personally got burned by this in deployment. The code worked, the demo worked too. QA was great. Then we rolled out on real devices, and because of camera sensor differences, we started hitting the risk band more often. Our branches started to flip, and of course the outputs changed as a result of that. And that created real business confusion because downstream logic expected the contour to be stable, but the contour was slightly larger on some objects and slightly tighter on the others. This led to false rejects and false accepts. And needless to say, this created real cost or the potential for real cost exposure. We had to fix it. I learned that the hard way, and since then I treat CV pipelines the way I treat remote telemetry devices. They have stable zones and they have ambiguous zones, and the ambiguous zones must be budgeted in the architecture. This problem doesn't care what model you use. It doesn't care if you run on Android or desktop or Jetson or a server farm or in the cloud. Wherever branching logic is sensitive to small histogram movement, you have risk bands. And that creates financial and time to market risk. If you want to reduce that risk, your job is not to eliminate it entirely. Your job is to detect when you entered that risk band and dampen the branch instability that your code is so sensitive to. There are several simple controls. Normalize illumination upstream. Use some kind of hysteresis around how boundaries or the branch trigger work. I call this branch inertia, where the pipeline does not flip branches unless there's like a sustained evidence. That's a little bit tricky to work on unless you have gained some experience with how your camera is set up, how your lighting, how your test setup, how your production setup, they behave, right? So make sure that you provision time and a little bit of cost for the effort, the labor that's involved in that exercise. Bake that in your project plan. What's the organizational payoff in all this? The organizational payoff is this. You make more informed decisions with respect to financial and time to market risk in computer vision projects by provisioning for unknown hiccups early instead of discovering them late. You don't surprise your stakeholders, and you manage your delays well, so that gives everyone more confidence. You don't roll into production and find out your contour numbers changed simply because your light temperature changed in production. Believe me, that is something you cannot underestimate. To wrap this up, the point of this video is not Android. Android is just the illustration surface. The point is, if your pipeline branches and those branches are sensitive to histogram movement, then you have a risk band. And you do care for that risk band. And if you don't acknowledge that risk band, measure it and control for it, you have delayed benefit realization. The payoff is to be aware of this early, so you can make more informed architectural decisions, more stable roadmaps, and more predictable delivery timelines.